Okay, so yesterday we talked about using the dual in order to solve a standard minimization simplex method problem. Okay, so today I'm just going to review those basic ideas again, and then we're going to set up a story problem. We're not going to solve it, we're just going to get it set up and talk about how you would read the solutions from that problem. Okay, so here, example 1, so this is that day 2 in your notes. Example 1, this is the final tableau in a standard maximization problem. Read the solutions. Now, I know this is the final tableau for a couple of reasons. The first reason is that all the numbers on the bottom row are positive. And then also, we haven't learned about this, but I know all of the variables have positive values at this point in time, and that's an important check to make sure you have a final tableau. So I know this is my final tableau. I know this comes from a standard maximization problems. That means that I'm looking for a maximum z, and then I also want all of my x values, x1, x2, x3. When you read a standard maximization problem, you're going to read it using that approach of basic or non-basic. Okay, so the first thing we're going to look for is the basic variables in this problem. Okay, here we go. So basic variables are the ones that have zeros in the columns and one number. So x1 is basic, it has a 2 in all zeros. x2 is basic, it has a 3 in all zeros. I'm scanning across. S3 is basic, it has a 1 in all zeros. And z is basic, it has a 2 in all zeros. So I should be able to solve for my variables by saying, okay, 2x1 equals 14. And if 2x1 equals 14, I can divide by 2. 14 divided by 2 is 7. The value of x1 is 7. x2 is basic. I can read that 3x2 is equal to 12. If 3x2 equals 12, then that means that x2 equals 4, because I can divide by 3. x3 is not basic. Since it is not basic, remember that we can just set that equal to 0. Now, it doesn't ask us for the value of the slack variables, but if we wanted to find the slack variables, we could say slack 1 is 0, slack 2 is 0, slack 3 is 11. Final one here, z, that says 2z is equal to 40. And if 2z is equal to 40, that means z, if we divide by 2, is 20. This is the solution to our standard maximization problem. Now, if this exact same tableau represented the solution in a standard minimum problem, remember we're looking for a little bit different information. We're looking for a minimum w, and we're looking for y's. Now, if I look across the top of this thing, I don't have any w's or y's, so I have to read the solutions a little bit different. Remember, the first thing you need to check for is that you want the coefficient on z to equal 1. Okay, so I need to scan down first. I see right now that my coefficient on z is equal to 2. That's a problem. So I'm going to take that last row in the matrix and I'm going to multiply by 1/2. So I'm going to take 1/2 of row 4. Okay, now I have to do that to all the numbers. So all of these numbers I'm going to cut in half. 2 divided by 2 is 1. 9 divided by 2 is 4.5. 2 divided by 2 is 1. 0, 1. 40 divided by 2 is 20. Okay. Now remember, if I have a 1 in the in the z column, then I know that my maximum w will be the same as my minimum. My maximum z ends up being the same as my minimum w. So I can read this as z equals 20. And the relationship between those dual problems is that means that the minimum value of the dual problem would also equal 20. The other thing we talked about was that the y's will come from the last row of those slack variables. Okay, so I look, and at the bottom of S1, I have 4.5. At the bottom of S2, I have 1. And at the bottom of S3, I have 0. Now, that's not what the slack variables equal. The slack variables equal 0, 0, and 11. But these numbers at the bottom indicate what our y values will be. So y1 is 4.5. y2 is 1, and y3 will be the 0 that's at the bottom of slack 3. And that's the solution to my standard minimization problem. So once you get to your final simplex tableau that has all positives in the last row, that has all positive variables, your reading of these problems are different depending on what kind of question you have. All right, so the next question, just as practice again, says set up the dual problem and then write the initial simplex tableau. Okay, set up the dual problem, write the initial simplex tableau. First thing I want to start off with is the matrix that has the coefficients in it. So I have y1 and y2, it looks like. My first constraint is 1, 2 with a 10. Remember, I'm ignoring the inequalities. I'm not adding any slack variables. I'm just setting up, I'm just bringing those coefficients out and putting them into a matrix. Then I have a 1 and a 1 and an 8 and a 2 and a 1 and a 12. I also want to put W in there. Okay, so my W would be 3 and 2. And then you can put a 0 as a placeholder there if you want to. You can even put a W there. It doesn't really matter. That last spot is just to have a spot in the matrix. Okay, I'm going to take this and find the transpose. Okay, the transpose matrix, remember, is when your rows become your columns. So my first row is going to become my first column in the transpose. So now I have 1, 2, 10 as the first column, 1, 1, 8 as the second column, 2, 1, 12 as the third column, and 3, 2, 0 as my fourth column. Need to separate out my last row and my last column. Remember that this last row is going to represent z. And then I would have an x for every column in front of where the constants are going to be. So I would have an x1, an x2, and an x3. Now I am ready to write my dual problem. So my dual problem should start off with the word minimize. And we're going to, not minimize. Silly Mrs. Leahy. I already have a minimize. The dual is a maximize. All right, maximize. And I'm going to use this last row. This is going to read z equals 10x1 plus 8x2 plus 12. Subject to. My constraints, I have two constraints. The first one is x1 plus x2 plus 2x3. And remember, in a standard minimum problem, all your inequalities are greater than, but in a standard maximum problem, all your inequalities are less than. So less than or equal to 3. And then 2x1 and x2 and x3, and that'll be less than or equal to 2. One more thing you always need to say, okay, we are existing in this simplex method world which has positive variables. So you need to make sure that you make a statement that says x1, x2, and x3 are equal to 0. Now that is the dual right there. So on your homework problems that say set up a dual problem, that is exactly what it's looking for. Okay, you don't have to go any farther. This question, however, asks us to also set up the initial simplex tableau. All right, so to do the simplex tableau, first thing I need to do is get some slack variables in here. So I know I'm going to add a slack 1 for the first constraint and a slack 2 for the second constraint. Eventually those are going to represent my y1 and y2 when I solve. The other thing we need to do is we need to subtract those variables over, remember. So we're going to take the 10x1 over to the other side, the 8x2 over to the other side, the 12x3, which I apparently forgot to write x3 on, and then you would have a positive z and equals to 0. All right, simplex tableau. x1, x2, x3. Okay, slack 1, slack 2, and z. First constraint is 1, 1, 1 with a slack 1, and it's equal to 3. Second constraint is 2, 1, 1 with a slack 2, and it's equal to 2. And my objective function is represented by negative 10, negative 8, negative 12. It has no slack variables, but it does have a z, and it's equal to 0. Just for funsies, let's go ahead and pick out the pivot. It's always fun to pick out a pivot. Okay, here we go. Oh, and I think I have a typo here. That should be a 2. There we go. All right, so I pick out the most negative column, that's the negative 12, and I'm going to test those two values of x3. If I pick 2x3 equals 3, that gives me a value of 1.5. So row 1 has a test value of 1.5. If I use the 1, I end up with 1x3 equals 2. That gives me a test value of 2. Okay. So my smallest test ratio in my most negative column is 1.5. So I'm going to go with the first row and the third column. Okay. Now this didn't ask us to go any farther, so we're not. Now we're going to set up this story problem, but we are not going to go ahead and solve it. I'm going to pop the solution up so you can see it. But let's go ahead and just get this set up for practice. 1 gram of soybean meal provides at least 2.5 units of vitamins and 5 calories. 1 gram of meat provides at least 4.5 units of vitamins and 3 calories. 1 gram of grain provides at least 5 units of vitamins and 10 calories. If a gram of soybean meal costs 7 cents, and a gram of meat costs 9 cents, and a gram of grain costs 11 cents, what mixture of these three ingredients will provide at least 60 units of vitamins and 66 calories per serving at a minimum cost, and then what will be the minimum cost? The first word that should jump out at you in this problem is the word minimum. Okay. That tells us that when we're talking about variables, we are going to use a W for our minimum. And for our variables, we're going to use like y1, y2, y3. All right, next thing we need to do is find our question. Our question says, what mixture of these three ingredients, okay, will provide at least, etc., etc. What mixture of these three ingredients? So we're looking for three ingredients, y1, y2, and y3. All right, now it's always really tempting to say things like vitamins and calories, but I haven't ever read a recipe that told me to add 47 vitamins and half a teaspoon of calories, okay? So we're going to think about what the actual things that we're talking about here. Look for the three. So notice we have a soybean meal, so I'm going to call soy, and we have meat and grain. Okay, so those are our variables. Now I'm going to go ahead and make my little table here. Soy, meat, grain, and we usually have totals as well. And I know that y1 is soy and y2 is meat and y3 is grain, but what mixture of these three ingredients? So you have to imagine what we're putting in there are grams of those. So that represents the amount of grams, the number of grams. Okay. All right. So I'm going to go through and try to pop information out of the problem. 1 gram of soybean meal provides at least 2.5 units of vitamins. That looks like a piece of information. 2.5 vitamins. And 5 calories. Calories, 5. 1 gram of meat provides at least 4.5 units of vitamins and 3 calories. 1 gram of grain provides at least 5 units of vitamins and 10 calories. Now, I'm assuming why they're saying at least here, where normally we would equate that with an inequality, would be because these are minimums depending on the type of meat, the type of grain, the type of soy that you have. So these are the minimums. You could have more. All right. If a gram of soybean meal costs 7 cents. Okay, now you have a couple options here. You could put in 7 as 7 cents, but then at the end, your answers will be in cents. So if you have like 2,000, then you have to figure out how many dollars that is. Or you could put it in as 0.07, and then your final answer will be in dollars, which is what I recommend because then you don't have to remember that. Now, if you don't like that later, you could always multiply through by 100 and get rid of those decimal places and make your numbers prettier for your arithmetic if you needed to. All right, a gram of meat is 9 cents, and a gram of grain costs 11 cents. What mixture of these three ingredients will provide, here it is, at least 60 units of vitamins, that's a total, 60, and at least 66 calories per serving, that's a total. And if I want at least, that means I want that number, or I would be very content with more. So we're talking about greater than or equal to's there for our symbols. I also want this to be the minimum cost. So my cost line is going to be minimum. Remember, I want my minimums to be set equal to W. And I'm ready to set up my problem. All right, I would like to minimize the equation W equals 0.07 y1 plus 0.09 y2 plus 0.11 y3. Subject to. Okay, my first constraint is 2.5 y1 plus 4.5 y2 plus 5y3 greater than or equal to 60. My second constraint is 5y1 plus 3y2 plus 10y3 greater than or equal to 66. And we need our not subject to when. Make sure you say that your variables are positive, because the last time I checked, you couldn't have -3 grams of soybean. That's weird. Okay. There's my standard minimization problem. Now that doesn't do me a whole lot of good because I don't know how to solve a standard minimization problem. So I'm going to convert this thing into a dual. Now if you are incredibly careful, and also if you make sure that your minimum is on the bottom line, you might be able to get to the dual problem straight from this little chart that you made, because it looks very matrixy when we do this. But I'm going to go ahead and go through those steps. Okay, so I'm going to take my coefficients from my constraints. Here we go. 2.5, 4.5, 5, and 60. And I'm going to take my coefficient from the second constraint, 5, 3, 10, and 66. And then my coefficients from the objective function without having done any manipulation of it, 0.07, 0.09, 0.11, and you can put a 0 as a placeholder in the corner. And I'm going to transpose this data. So I'm going to take my first row and turn it into my first column. 2.5, 4.5, 5, and 60. 5, 3, 10, 66. 0.07, 0.09, 0.11, and 0. I know that in the dual problem that the last line is going to represent a z instead of w. I also noticed that I'm going to have an x1 and an x2, but not an x3. X3 is not there. Those are just constants. And here is my standard maximum problem, the dual. The maximum equation I want to do is 60x1 plus 66x2. My subject to my first constraint, first constraint is 2.5x1 and 5x2. Since I'm talking about a standard maximum problem, all my greater thans are going to flip and become less thans. So that's a less than or equal to 7 cents. I've got 4.5x1 and 3x2 less than or equal to 0.09, and 5x1 plus 10x2 less than or equal to 0.11. I can also say that my variables are positive. Okay. Okay, now just for sake of time, and because I really don't feel like you need to hear me do massive quantities of row operations over this audio, I'm going to go ahead and flip over to my key to this. This key is posted on Schoology in the Chapter 4 folder in the course notes and notes key subfolder, so you can actually look at this yourself when you get there. It's also on my, I believe, on my classroom website as well, if you want to get it from there. Okay, so what we would do next is we would take these values, we would subtract our x's over, and we would add 3 slack variables in. Okay, and that gives me a, see if I can get this to look a little better here. There's a lot of work. Okay, so here's the minimization. Go back up to the top. All right, so that gives me what I have over here on this right-hand side. So here would be my first simplex tableau. Take the first simplex tableau and I find my most negative column. It's a -66, and I would do a test ratio, 0.014, 0.03, and 0.11. That gives me a 10. I'm going to do my row operations. Notice I used row 3 in all those row operations, and I get this second tableau. In the second tableau, I know I'm not finished because I have a -135 down there. That makes me sad. Okay, so I need to test again. Now, the nice thing about this problem is that there's already a 0 in the first column, so you know that you're not going to use that. You need a small positive number, and so that's not going to work. Okay, so you get to keep that one as a bonus. If you go to test these other, 30x1 equals 0.57, you get 0.019. 5x1 equals 0.11, you get 0.022. That tells me that my test value is going to be the 30 because it's the smallest test ratio. I'm going to pivot there. Okay, if I do those row operations right here, notice I use row 2. I don't have to do a row operation with row 1. I only have to do one with row 3 and row 4. I get a simplex tableau that looks like this. Okay, When I take my Simplex Tableau from here, I notice that I'm solving a standard minimization problem, so z has to be equal to 1. So I divide out the 10. Okay, I had all positive numbers, but I divide out the 10, and I actually get my answers from this bottom row here. So my minimum cost, my W, is the same as Z, which I'm going to put as $1.24 instead of 1.239, since it's money. And then I've got 0, 9, and 3.9 as the amount of soy, meat, and grain. And again, I read the problem that way because it is a standard minimum. All right, your job today is to finish your section 4.3 homework from yesterday. That is due next time I see your faces, which I believe is tomorrow as long as I am here. So that 4.3 homework due tomorrow. If you have any questions, you can email me or message me through Schoology. The key to this notes is also on the classroom website and on Schoology. So if you missed anything as we were going through here, you can go back on there and fix that. Have a wonderful day.